Welcome! Are you excited for another fun learning experience? Let's go! Today's science lesson is What's in a mole? Before we begin, make sure you have the following: pen, paper, a copy of your SLK Week 7, and periodic table. Class rules. Be attentive and listen carefully. Participate in the discussion. Even if you are far away from me, you can still participate by answering some of the questions that I will raise in today's lesson. The learning competency for this lesson is use the mole concept to express mass of substances. Objectives for today include recall counting units that is used to express the measure of objects. Understand the concept of mole and its relationship to the number of particles. Apply Avogadro's number to determine the number of representative particles in a substance. Calculate the molecular mass or formula mass to obtain the molar mass of a substance. Determine the mass of 1 mole of a substance. Show the calculation of finding the molar mass of a given substance. Appreciate the role of mole concept in other industries like food, pharmaceutical, and manufacturing industries. Recognize the significance of the contribution of Avogadro in the field of science. Before we continue, let's have a pretest. The pretest will test your previous knowledge of the given topic. First item. Cheska measure the mass of 10 pieces of each of the following materials: marbles, pebbles, and ballpen caps. What will be her findings based on the data she obtained? Marbles, 50 grams. Pebbles, 35 grams. Ballpen caps, 20 grams. A. Different materials have different masses. B. Materials of different kinds differ in amount, color, and texture. C. The same number of materials has different colors and appearance. D. The same number of materials of different kinds has different masses. I'll give you 5 seconds to answer. And yes, the correct answer is letter D. The same number of materials of different kinds has different masses. How many particles are in 1 mole of a substance? A. 6.02 times 10 to the 22 particles. B. 6.02 times 10 to the 24 particles. C. 6.02 times 10 to the 23 particles. D. 6.02 times 10 to 25 particles. 5 seconds to answer. Yes, the correct answer is letter C. 6.02 times 10 to the 23 particles. Which of the following units is used to express the amount of substance in terms of the number of particles? A. Liter. B. Degree Celsius. C. Gram. D. Mole. 5 seconds to answer. You can make your wild guess. And the correct answer is letter D. Mole. What does 1 mole of water molecule represent? A. 6.02 times 10 to the negative 23 molecules of water. B. 6.02 times 10 to the 23 molecules of water. C. 6.02 times 10 to the negative 24 molecules of water. Or D. 6.02 times 10 to the 24 molecules of water. You got it right. If you answered B, that's correct. 6.02 times 10 to the 23 molecules of water. Which of the following has the smallest molecular mass? A. N2 or nitrogen gas. B. H2O or water, C, CH4 or methane, or D, NH3 or ammonia. I know this is difficult. Maybe you're not familiar with other substances, but just make your wild guess. And if you guess it's letter C, then you're correct. CH4 or methane has the smallest molecular mass. Now this is activity 1. Examples and illustrations are provided. What we have to do is determine the number of pieces of objects in each counting units. So we have here pair, and what is the number of pieces that represents pair? Okay, from the picture you have there two pieces of shoes. And here, another picture, you have 2 pieces of slippers. How about for a dozen? A dozen means 12 pieces. Okay, if you order 1 dozen of roses, then it would mean 12 pieces of roses. And if you order, or when you go to a supermarket and you buy 1 pack of 1 dozen eggs, then you will surely find that there are 12 eggs in the pack. So that's a dozen. 12 pieces. Ream. What about ream? How many number of pieces are there? Can you count them? Oh, that's difficult to count. But a ream has 500 pieces. So if you have this sticky notes that is equal to 1 ream, then you will surely find that there are 500 pieces of sticky notes. If you order in the National Bookstore or any school supply store 1 ream of bond paper, then you will find that there are 500 pieces of bond paper. Counting units represent a specific number. Like pair, it is representing 2 pieces. For a dozen, it represents 12 pieces. And a ream represents 500 pieces. Now, in science, you will also find that there is a counting unit that represents a number of particles. And that is what we call mole. Now, this number is very large because, of course, particles that composes an object are very small. Therefore, you can really find that these particles are in a very large number. Now, what is that number? A mole is represented by Avogadro's number, which is equal to 6.02 times 10 to the 23 number of particles. Now, if this number, 6.02 times 10 to the 23, is the number of dollars or 1 peso that you will have, that would mean that by the age of 100, you will still have more money left, which means you cannot spend all of these money. It's really, really large. It's really, really big amount. That is the meaning, or that is the connotation of having this large number. Mole is represented by Avogadro's number, which is 6.02 times 10 to the 23 particles. So if dozen means there are 12 number of pieces, if a ream means 500 number of pieces, then a mole is much, much greater, and that means 6.02 times 10 to the 23 number of particles. Now let's go to another activity. What can you say about the number of pieces of objects in the picture? How do each of the masses compare? Now, of course, in the picture you will find 1 dozen of spoon, 1 dozen of cotton buds, 1 dozen of binder clips, which means there are 12 number of pieces of spoon, 12 number of pieces of cotton buds, and 12 number of pieces of binder clips. 1 dozen. It always means 12 pieces. So if you have a dozen of spoon, it means 12 pieces of spoon. A dozen cotton buds, 12 pieces of cotton buds. A dozen clips, 12 pieces of clips. If you go visit Dunkin' Donuts and buy a dozen donuts, when you open the box, you will surely find 12 pieces of donuts. Yes, that is always true. 1 dozen is 12 pieces. And wherever you go, even if you are in the Philippines, a dozen is 12 pieces. If you go to the US, 1 dozen there is also 12 pieces. But to answer the question in the activity, how do the masses compare? The masses of every dozen of different objects in the activity differ, meaning they are different. Why? Now, 12 pieces of spoon is more massive or the most massive among the 3 objects. The cotton buds is less massive, while the binder clips is massive by itself. Now, there are 12 pieces of each of these objects, but then still their masses would be different, even if they are of the same number. In science, we can represent mole to be always 6.02 times 10 to the 23 particles. And the particles can be atoms, molecules, or formula units. The atoms represent the elements. The molecules represent the covalent compounds. And the formula units represent the ionic compounds. I hope you still remember your lesson about covalent compounds and ionic compounds. Now, 1 mole of carbon is always equal to 6.02 times 10 to the 23 carbon atoms. 1 mole of oxygen gas is always equal to 6.02 times 10 to the 23 oxygen molecules, while 1 mole of sodium chloride is equal to 6.02 times 10 to the 23 NaCl formula units. That's 1 mole. 1 mole, 1 mole. But these are different substances. But because they are 1 mole of each, then they always have the same number, which is 6.02 times 10 to the 23 number of particles. Now, what about the masses? As what we have known from dozens or from a dozen, even if you have a dozen of spoons and a dozen of cotton buds, even if they have similar number of pieces, but they are of different objects, they are of different materials, then therefore they have different masses. The same is true with substances. They have different masses even if they have the same number of pieces or particles. But because they are of different materials, then they are of different masses. Now, how to find for the mass of these materials or substances when you cannot count 6.02 times 10 to the 23 particles? Now, how do we get to know the mass of the 6.02 times 10 to the 23 particles? What we have to know is the molar mass. And the molar mass is the mass of 1 mole of a substance. It is related to the atomic mass or the molecular mass or the formula mass. Now we will get to know these 3 masses as we proceed. Atomic mass is the mass of 1 atom only. Now in the example, we have here carbon atom. Now we're going to need the help of the periodic table, because in the periodic table you will find the mass of the atom, which is labeled as atomic mass or average atomic mass. For carbon, it's 12.011, or I just have to round it off to 2 decimal places, that is 12.01. And the unit is AMU, or atomic mass unit, and that is the mass of 1 carbon atom only. Now, if we have 1 mole of carbon having 6.02 times 10 to the 23 carbon atoms, then the mass of that number of carbon atoms will be equal in figure with the atomic mass, that is 12.01, but the unit is in grams. Now, the 12.01 atomic mass unit, or the mass of 1 carbon atom only, cannot be seen or cannot be collected from a laboratory. But if we wanted to know or to get 12.01 grams from the laboratory or using a weighing scale or a digital scale, then that would be possible already. And this means that the 12.01 grams of carbon would actually have this number of atoms, which is 6.02 times 10 to the 23 carbon atoms. Now, what about the molecular mass? The same. We are going to use the molecular mass to know the molar mass. The mass of 1 molecule of a covalent compound is what we mean by molecular mass. Now, molecular mass is true for covalent compound, and an example here is oxygen. Oxygen does not exist alone. Naturally, it exists as diatoms, meaning 2 atoms. The subscript here means 2 atoms. Now we will need the help of the periodic table, and we will find there oxygen. And below it, you will find the average atomic mass, which is 15.999. And we're going to substitute, we have to round it off to decimal places, or 2 decimal places. I just omitted the decimal places because we will only have 16.00. So I just write here 16. And the unit for the molecules mass is AMU, or atomic mass unit. And we have here 2 because we have 2 atoms of oxygen, given here the subscript 2. And therefore we will get total of 32 atomic mass unit. And this is the mass of 1 molecule of oxygen alone. 1 molecule only. Now, if we wanted to get the mass of the 6.02 times 10 to the 23 oxygen molecules, or the 1 mole of oxygen, then we get to use 32 from the molecular mass, and we will be having or described it as grams. So 32 grams is equivalent to 1 mole of oxygen, which is equivalent to 6.02 times 10 to the 23 oxygen molecules. So since particles are very small, we cannot count them one by one, and if we wanted to get 1 mole of oxygen, or if we wanted to get 6.02 times 10 to the 23 oxygen molecules, all we have to do is weigh 32 grams of oxygen, and then you will get the number of molecules of oxygen that you wanted, which is 6.02 times 10 to the 23. Now, the same is true for formula mass. Formula mass is the mass of one formula unit of an ionic compound. And the example here we have NaCl, or sodium chloride. Sodium chloride is the salt that we have in the kitchen that we use to season our food, or that's asin in our vernacular. Now, NaCl, or sodium chloride, has two elements that comprises it. We have Na, or sodium, and Cl, or chlorine. And Na has an atomic mass of 22.99 atomic mass unit. Chlorine has 35.45 atomic mass unit. And we have to add together the atomic masses of the two component elements, and we get 58.44 atomic mass unit. This is the mass of only one NaCl formula unit. Now, if we want to get the molar mass, all you have to do is use the figure 58.44 and use the unit grams to express the molar mass. So this 58.44 grams is the mass of 1 mole of NaCl, and that is equivalent to 6.02 times 10 to the 23 NaCl formula units. And this can be prepared or obtained in the laboratory, or if you have a small weighing scale at home and you wanted to get 6.02 times 10 to the 23 NaCl formula units, just weigh 58.44 grams of NaCl, or sodium chloride. And that is equivalent already to 6.02 times 10 to the 23 NaCl formula units. So the molar mass of objects or substances differ because of the different elements that makes up the compounds. And obtaining the information of the mass of a substance using the mole concept is a great help in food industries, manufacturing industries, and pharmaceutical industries in making their own products. So we have food industries like in your TLE, maybe you will use right amounts of ingredients. Then that is one way that is being used by food industries or manufacturing industries, so that they can have a perfectly blended combination of ingredients, and to be able to have the right product that they want to produce. The same is true for food and beverages And for manufacturing industries, like industries that promotes or produces detergents, shampoos, and other materials, and most especially in pharmaceutical industries, where the amount of ingredients of the compounds or the chemicals has to be perfect and correct, because they use this for the health or treatment of every individual, living, humans, um, plants, and even animals. So the information that we can get from the mole concept is really very helpful into these industries. And not only that, we can also use the mole concept by helping environmentalists to monitor the pollutants in the air, or even the amount of gases that can be exposed or produced into or released into the environment, that is harmful to the environment, that could be known or that could be um, expected coming from the mole concept. And so let's proceed. Now let's proceed. For your assessment, you're going to answer the exercise on page 9 of your SLK. You have to show your solution, just like the solution that you can find in your book or SLK. You'll have their sample solutions, and just like the solution that I will be showing to you after this slide, you have to make your own solutions to some of the items that you have to answer. Now, we have here the exercise. Here, you have to fill in the table with the correct answer. Below the name of substance, indicate whether it's a molecule or a formula unit. So you have here blank. You have to write, is this a molecule or formula unit? You have to write the whole word, okay? Now, you have here the molar mass and the number of particles. So just have to remember, if there's 1 mole, then that means how many particles? Just like 1 dozen means 12 number of pieces, then 1 mole will always mean, maybe you have it in your mind. Yes, correct. It means 6.02 times 10 to the 23 particles. You will never forget this. Promise. I will show you a picture of why not. Okay? And then we're going to show the solution in solving for the molar mass. But I already have here an example. So for water or H2O, you have to get the help of the periodic table to find for the atomic mass of each of the component elements. So we have hydrogen and oxygen. From the periodic table, you will find 1.01 as the atomic mass of hydrogen. And since in the formula of water, it's you have there H2O, means the 2 here means 2 atoms of hydrogen. So you have to multiply it by 2 atoms and you get 2.02 AMU. For oxygen, you only have 1 atom. Nothing is written here, but it already means that there's 1 atom, or that represents 1 atom only. And from the periodic table, you get 16 AMU, and then finally you have 16 AMU. And add the 2 atomic masses of the component elements, and you will find that the molecular mass, why molecular mass? Because H2O is a covalent compound and it is represented by molecules. The molecular mass is 18.02 AMU per molecule. So one molecule of water has 18.02 atomic mass. Now, for molar mass, then you are going to just use the figure 18.02, then use grams per mole, meaning 1 mole of water has 18.02 grams. Okay? Now, the same is true for ethyl alcohol. You have to identify the component elements. We have carbon, hydrogen, and oxygen. We have to get the atomic mass using the periodic table. For carbon, it's 12.01. For hydrogen, it's 1.01. For oxygen, it's 16. And identify the number of atoms. You have 2 for carbon. And we have 6. 6 for hydrogen. Maybe you will find here 5, but you see there's another 1 hydrogen here. That makes it 6 atoms. And oxygen has 1 atom only. And then multiply, you get 24.02 for carbon, 16.06 for hydrogen, and 16 AMU for oxygen. Now, add everything, you will get 46.08 AMU per molecule. So, one molecule of ethyl alcohol has a molecular mass of 46.028 AMU. And given that, you can use it for expressing the molar mass, 46.08, and use the grams and per mole units, meaning there are 46.08 grams in 1 mole of ethyl alcohol. Now class, I'm already showing to you here the answers for the molar mass of calcium fluoride. This is table sugar and this is vitamin C. All you have to do is show to me the solutions for calculating these numbers here, and then of course you have to complete the table that is provided in your SLK, and by the time that you're going to submit to me your answer sheets, I will be finding a complete answer in the table that is in the exercise. And do not forget to identify the particle, the representative particle. Is it a molecule or a formula unit? Okay, don't forget that the particle for covalent compounds is molecule, and the particle for ionic compounds is formula unit. Now here's an assignment, class. Since mole concept is very helpful in so many industries in the world, I want you to make a photo collage or write an essay, or you can compose a song that expresses the importance, or there's O here, sorry for the clerical error, or the usefulness of the mole concept. With that, you'll be showing to me your understanding of the topic. At the same time, you can choose your way of expressing the usefulness of the mole concept. So just choose, class, if you want the photo collage, an essay, or a song composition. That's your call. Okay? And when I told you that you'll never forget the number of Avogadro, it's because Happy Mole Day. Okay? Happy Mole Day is celebrated every October 23. October 23 is 10. October is 10, and then 23, 10 to the power of 23. And this is mole. You see? 6.02 times 10 to the 23. 10 October 23 and 6 a.m. to 6 p.m. That is the time for celebrating Happy Mole Day. Why? Why is this being done? This is to honor or to recognize the contribution of Amedeo Avogadro, who discovered the mole and assigned it or represented it with 6.02 times 10 to the 23 number of particles. So that's also one way that we can honor the scientist who has greatly contributed to the field of science. So without these scientists, maybe we will not be enjoying the correct or the perfect products that we are enjoying right now, and most especially with the medicines that we are taking, even with the preparation of vaccines like COVID vaccines. They are also using mole concept because it is an important product that we people have to benefit from. Okay, so not only people but also plants and animals and all living organisms benefit from mole concept, given that scientists are making products or manufacturers are making products that can be beneficial for the lives of every human beings. And that would be all. Thank you so much for attending. Thank you so much for watching. And you may check my YouTube channel for this video lesson if you want to review the discussion. And also you may subscribe to my channel for more video lessons. Especially to those who have not joined or right away who cannot access the video. You can access it later when you have internet available or when you have the time available. You already have no work to do, or when you have spare time, you can review the discussion. Just click on YouTube and you will find this video lesson. I will also be sending the link in our GC, so do not forget to also check our GC for you to have an easy access of the YouTube video channel that I have. Goodbye and thank you so much. See you next time and have a wonderful day. Bye bye.